Hi guys, welcome to our SG90 YouTube channel. Today we are going to build this automated gate system using an Arduino Uno. This gate will automatically open when a vehicle approaches the gate and close after the vehicle passes through. It's a simple but practical automation project that demonstrates how sensors and actuators work together. If you enjoy learning, building, and improving things by yourself, make sure to subscribe and hit the bell icon so you don't miss our upcoming videos. First, let's look at the main components we need for this project. Here we need an Arduino Uno, 2 HC-SR04 Ultrasonic Sensors, 1 SG90 Micro Servo Motor, and a breadboard. These components will help us detect vehicles and control the gate automatically. Now let's take a look at the circuit diagram. In this system, we are using two ultrasonic sensors. One sensor is placed on one side of the gate, while the other sensor is placed on the opposite side. If we first think about a one-way traffic situation, the sensor placed before the gate detects a vehicle as it approaches. When the vehicle comes within the detection range, the system recognizes that a vehicle is waiting and the gate automatically opens. As the vehicle moves through the gate and continues forward, the second sensor detects that the vehicle has passed the gate. Once the vehicle leaves the detection area, the system understands that the path is clear and the gate closes again. Because we have sensors on both sides of the gate, the system is not limited to one direction. Vehicles can approach from either side, and the gate will still operate correctly. The system simply detects the vehicle from whichever side it arrives and automatically opens and closes the gate. Before we start building the project, let's quickly discuss a basic concept in system design. In many electronics projects, including this one, the system can be divided into three main parts as input, process, output. Almost every electronic system follows this same structure. The input is how the system receives information. Inputs can include sensors, button presses, user commands. In our project, the ultrasonic sensors act as the input devices, detecting the presence of a vehicle. Next comes the processing stage. Here, the Arduino Uno reads the sensor data and processes it according to the logic we programmed. Based on the sensor readings, the Arduino decides whether the gate should open or close. Finally, we have the output. Outputs are the components that perform actions or show results, such as motors. LEDs displays buzzers. In this project, the servo motor acts as the output device, physically moving the gate. Now that we understand the system architecture, let's move on to building the circuit. I assembled the circuit on a breadboard and created a simple setup to simulate a car park gate. For the structure, I used cardboard and a few basic materials that are easy to find at home. This helps us visualize how the system would work in a real scenario without needing any complex tools or expensive parts. In this setup, I powered the servo directly from the 5-volt output of the Arduino Uno. In general, this is not considered a good practice. Servo motors can sometimes draw a relatively high current, especially when they start moving or when they are under load. If a servo pulls too much current directly from the Arduino board, it can cause instability or even damage the board. However, in this particular project, the servo motor is moving a very light cardboard gate, so the load on the motor is quite small. Because of that, powering it from the Arduino's 5-volt pin works fine for this simple prototype or this project. Alright, now that our hardware setup is ready, let's take a look at the code. I slightly modified the measure distance method that we used in our previous project. In the earlier project, the function was designed to work with a single ultrasonic sensor. But in this system, we are using two sensors, one on each side of the gate. So I updated the method in a way that it can be reused for both sensors without writing the same code twice. Now the function simply takes the trigger pin and echo pin as parameters, measures the distance using those pins, and then returns the calculated distance. This makes the code much cleaner and easier to maintain, because the same function can be called for each sensor whenever we need to measure the distance. To make debugging and testing easier, I also enabled the serial monitor in the Arduino code. This allows us to print the distance readings from both sensors in real time. By watching the values in the serial monitor, we can clearly see how the sensor readings change as an object moves closer or farther away. This is a very useful technique when working with sensors, because it helps us understand what the system is actually detecting and makes it much easier to fine-tune the distance thresholds if needed. Once the code is uploaded, we can start testing the setup. As you can see, When an object or a vehicle comes close to one of the ultrasonic sensors, the system detects it and the gate opens automatically. After the vehicle passes through and leaves the detection area, the gate closes again. The system behaves exactly as we expected. Now that the basic system is working, you can start thinking about ways to improve it by adding new features. One interesting direction would be turning this simple automated gate into a smart parking management system. Instead of only opening and closing the gate, the system could also keep track of how many parking slots are available inside the parking area. If this sounds interesting, you can give it a try and experiment with the idea. In fact, this is exactly the kind of feature we'll explore in more detail in one of our upcoming projects, where we'll build a more complete smart parking system step by step. That's it for today's project. If you enjoyed this video, don't forget to like and subscribe. See you in the next project.